Hello, everybody. Welcome back to Planet X News. We are here today with our Planet X physicist. We're going to be discussing sunspots, and she's prepared a report on sunspots to give us a better understanding of some of the things that do go on the sun. And I'd like to say, good morning, doctor. How are you?
Good morning, Scott. I'm fine, thank you. And how are you?
I'm doing pretty good. It's been a rather long morning. Ladies and gentlemen, we had a live stream much earlier. For some people, it was in the middle of the night. For some people, it was early in the morning, and for some people, it was early afternoon. But we were discussing what was currently happening with our magnetosphere and what we were observing on the magnetosphere model. And if you did not catch that live stream, it is just under 2 hours. It's posted on the Nibiru channel, the Planet X News channel, and it has also been uploaded to Chris Potter's channel. But we're going to go ahead and get directly into this report on the sunspots, because last week we had a very big sunspot turning towards Earth. I believe it was labeled AR 2661, and we were seeing a lot of activity from that sunspot, and it was kind of just above the sun's equator, and that's kind of where Earth lies. So anything that occurs in that region, such as a coronal mass ejection, these filament releases, these are directly Earth-facing. So we were kind of worried, I was kind of worried, that once that big sunspot with all of that activity got to its point where it was Earth-facing, that if there was some really big action on that sunspot, well, we would have some serious problems here on Earth. And the majority of those problems, ladies and gentlemen, they'll have to do with cell phone outages, power outages, things of that nature. But it seems it was kind of a, well, maybe like a non-event, but there were power outages. There were serious issues with several of the major U.S. cell phone carriers. I mean, I was getting the emails just about every minute of the day pertaining to cell phone outages, problems with the internet, and there were quite a few power outages across the United States. I'm not too sure about other countries, although I did hear there was a power outage over in the UK. I'm not real familiar with the area where that occurred, but the doctor wrote a report on the sunspots because we've seen a pretty big absence of these coronal holes. We've also seen the solar wind has really died down to a very low speed. Some of these things, you know, we're kind of looking at very closely. And I did ask the doctor if she could, you know, do a report on these sunspots to give all of us a better understanding of what they are, you know, possibly how they occur, and what type of threat do these sunspots have towards Earth. So, doctor, I'm going to go ahead and turn it right over to you, and I'm going to go ahead and pull up your report. Just give me a second to get my screen share. And voila. Title of the article, Sunspots, what are they and what can they tell us about the sun? Okay, the stage is all yours.
Okay, so sunspots are regions on the sun's surface where the magnetic field is very intense. So here in figure 1, we see our image from 2010, and the sun's magnetic field has been mapped on it. You see specifically 2 regions where the magnetic field lines are very concentrated. They lie very close together, or there were a lot of field lines coming out of those regions, and they indicated by the blue arrows. So these are regions on the sun where there will be a lot of sunspots. Sunspots don't just occur as one, they usually occur in groups. So we can see it's quite interesting how the magnetic field lines, you see that they form these loops, and how they come out of one area. That's where the sunspots are. So if we scroll down a little bit, I think I explain what happens in these sunspots. Okay.
Yeah, this was an amazing picture, by the way.
Yeah.
That deep, that high resolution of a sunspot, that's pretty cool.
Yeah. Thank you. So what happens is above the sunspots, there are all these magnetic field lines, and the particles, the plasma in the sun, spirals along these field lines. So it's carried way up above the surface of the sun. And then what's left behind is basically a hole in the sun's layer called the photosphere. It's often thought of as the surface of the sun. And this is what these holes look like. As you can see here, the center is black, it's very dark. And around that, there's a darker region, it looks brown. So the black is called the umbra, and the brown is called the penumbra. And then there are small sunspots that sometimes just look black. They don't have a penumbra. Those would be called pores. But we also see the Earth is drawn there to scale so we can compare the size. So most sunspots are larger than the Earth.
Oh my, that could swallow the Earth right up.
That's right. So that's how large they are. Now, what else happens is the temperature inside the sunspot is cooler than the surface of the sun, or the surface of the photosphere. And the surface temperature is about 5,800 Kelvin. And the temperature at the bottom of these sunspots is about 2,000 degrees below, 3,800. So it's much cooler inside there. Also, there's quite a height difference. This is a hole right through the photosphere, which is 500 kilometers deep.
Wow.
Yeah, so the umbra is actually like the walls, like canyons, where you go straight down into the bottom. So what I think is happening here is we are actually looking into the interior of the sun. And as we can see, it looks dark, it's darker and cooler. And that tells us a lot about the sun, which is later on I corroborate with something else that I've done. So
wow,
okay,
you know,
we can.
If you didn't have these areas labeled and you didn't have the Earth in this photograph, and just showed this photograph to, you know, just anyone, I mean, it almost looks like a flower.
It does indeed.
Yeah, it's very, very neat.
It looks like.
Yeah, I've never seen a photograph in that detail, that up close and with really good resolution of one of these sunspots. It's pretty amazing. Let me get us back to.
The sun is quite beautiful. It's quite interesting to study the sun. Anyway, this shows you what the sunspots look like. They actually come in pairs, because if the magnetic field lines flow out of one, they have to flow into another one. So there's never just one single one. There's always a pair of them. They are connected by the magnetic field. And one of them will be said to have a north polarity. That's why there's a little red N next to one. And that's the one where the field lines flow out of it. And then there will be the other one, the pair, which has south polarity, and the field lines flow into that sunspot.
So that's why we see these like I guess like a filament release and a filament or plasma loop that goes back and
Yes.
forth, back and forth.
Yes.
Yeah, that's pretty.
That's right. Yeah. So the particles, the ionized particles that make up the sun's plasma, spiral along these field lines, and therefore, and they glow. So that's why we see plasma loops, because there is plasma flowing along these field lines, and therefore making this loop shape.
Yeah, I'm always looking for those. Whenever I'm looking at the SDO footage, the one wavelength where the sun is that real deep red color, you could see these loops quite often, and it is a sight to see, and then realizing how large the sun is, and then as you showed that sunspot with the comparison of the size of the Earth. That's pretty amazing that the Earth can just be swallowed up by one of these sunspots. You know, I mean, we know that's not reality, but that was a pretty good comparison. That was good. I like that.
Thank you. Now, it's good that people realize how big these structures are on the sun. Don't forget, the sun is in size 100 times larger than the Earth. It's a main sequence star. It's large. Well, it's relatively small compared with the kind of sizes stars can have, but in terms of planets in the solar system, it's huge. Okay, so then I go on to describe the sun cycle. It's got a 11-year cycle, and that has to do with the sunspot. So during the solar maximum, there will be lots of sunspots on the sun. And during the solar minimum, there will be sometimes many days where there are no sunspots at all. So there is this 11-year cycle. But the sun has to do with the polarity of the sunspots. So, and that I explain with this image. So in cycle A, you see we have two, in the northern hemisphere of the sun, there are two sunspot groups. But the leading one is always the north polarity sunspot. So there's a north and there's a south. And then in the next group, there's a north and there's a south. If you go down to the southern hemisphere, you see that the leading sunspot is a south polarity sunspot. So the south is the one on the right, because we read from right to left. So the leading one, and the sun also rotates from left to right. So the leading one, the one you will see first, is the south one. And this is in the southern hemisphere. And then the second one will be the north. And in the next group, the same thing. So this is what would happen during one particular cycle. And it's 11 years long. Then if you move on to the next cycle, so after a solar minimum, then you move on to the next cycle, and then sunspots start to appearing with the polarity reversed. So now in the northern hemisphere, the leading sunspots are the south polarity sunspots, and the north comes second. If you move down to the southern hemisphere of the sun in the cycle 8.1, the north polarity sunspot shows up first, and then the south polarity one. So what has happened is the sun has reversed its polarity from one cycle to the next. That's how we think of it. And then if we go on to the next cycle, which would be cycle 8+2, we would go back to the same polarity arrangement we see in the left diagram for cycle A. So that means it takes 22 years for the sun to go back to its original polarity arrangement. So that means it's got a 22-year cycle to do with this.
Well, that's a long time. That's a long time, 22 years.
That's right. It is. The sun has a long polarity cycle, polarity reversal cycle.
I mean, that's like almost like a third of a human being's life.
That's true. Yes. We're not very long-lived compared with stars. Stars live for millions of years. So here I say these images where we see the polarity of the sunspots are called magnetograms. And if we have a black and white one, the white shows north polarity, and the black are south polarity sunspots. And this is not just one or two sunspots. These are groups of sunspots. So you get a group of white sunspots and then a group of black sunspots next to it. And in the color magnetogram, the green is the south polarity and the yellow is the north polarity. So
now,
you were asking me about that. Yeah.
What is the difference between, if you know, the green shaded area that is to the left of the sunspot? Is that also part of it?
What is the difference? The magnetic field lines flow out of the south polarity and they flow into the north polarity. So if we have particles flowing, the plasma would basically follow those same directions.
Boy, that looks like a pretty big sunspot that you captured there, number 25, 29 in that image.
Yes. Yes, I'm not sure how recent it is. It may be from earlier this year. I cannot quite see the date there.
Yeah, I can't see it either. It's very, very small.
But I think it is from this year.
Yeah, that's a big sunspot right there.
Yeah, that's an intense activity sunspot. And they are more active because the field lines are so close together. So that causes pressure in the field lines. And when they have pressure, what happens is we have magnetic reconnections. And then when we have these magnetic reconnections, we have huge releases of energy. And these releases of energy explode out of the sun as what we call sun flares. It's a huge amount of radiation. And the radiation that explodes out of these magnetic reconnections ranges from radio waves all the way to gamma rays. But they usually viewed in X-rays. They usually emit in X-rays. And here I explain in this diagram what happened. So we start off with the north-south pair of sunspots, and the magnetic field lines come out of it, like we see there, forming these loops, and then they stretch outwards, and they stretch outwards more and more. They start to pinch, and when they eventually pinch close enough together, we get a magnetic reconnection. So the magnetic field lines change direction, and we get the round part above and then the looped part that moves downwards. That releases a lot of energy. So we would get sun flares coming out of there. And also when the magnetic field lines separate like that, some of the particles are then free to move upwards. And that's what creates CMEs. We don't always get CMEs though, because the CMEs, the particles that are released, there are always particles released, but they don't always manage to escape the sun's grasp. So only when they are able to escape, because the sun grabs onto them, that's how it grabs onto its gas and pulls it towards its surface. But these particles are accelerated to nearly the speed of light. So sometimes they manage to escape the sun's grasp, and then once they have done that, they are accelerated, and they can move at speeds of up to 1,000 kilometers per hour, which is 2.2 million miles per hour.
Oh Lord, I think we had a close. I think we had something very close to that type of speed this past winter. When the solar wind reached I think it was 1.6, 1.7 million miles per hour.
Mm-hmm. Yeah.
Yeah, it's pretty.
Yeah. So that
pretty amazing.
it is amazing. We also get those speeds out of coronal holes. Fast wind speed out of coronal holes also accelerates outwards at those speeds. But these are the speeds for CMEs. And they also can travel extremely fast. And those that travel that fast are usually associated with very strong solar flares. And the solar flares, I don't even have this here. They categorize them with letters. So they go B, C, M, and X. And X are the strongest solar flares that we've seen so far. And then we get faster and larger CMEs associated with those as well.
Okay, then you're referring to the class of CMEs or flares.
Solar
flares.
Solar flares, yeah.
Yeah. And what do we have here? Conventional theory. Conventional theory.
Yes. Okay, so the conventional theory states that the sun is powered by fusion reactions, the core. But what we see in sunspots is that the sun is cool and dark on the inside. Now, if the sun was having fusion reactions on the inside, it would be creating a lot of heat and a lot of light, and that light would be continuously coming from inside the sun. However, what we see is that sunspots inside are cool and dark. And that should not be possible if we have heat coming from the inside of the sun and we have lots of light coming from inside of the sun. So what I say is that sunspots, to me, reveal the fact that the sun is dark and cool on the inside, and therefore, it's not possible that the sun is powered by fusion reactions. And then I corroborate that with my own observation of the sun, which I have been doing for quite a few months. And one of these is the Solar Dynamics Observatory eclipse season, where I have observed that the sun actually goes dark. And then there were other times, so this happens twice a year, and there are other times during the year where I have observed the sun going partially dark. And that's when these cutoff lines are used and to hide the fact that the sun's going partially dark. But if you examine the images carefully, you can see clearly that the sun's going partially dark. But during the SDO eclipse season, it goes completely dark, progressively, and then eventually completely, but not on the first day. The first day goes dark slowly, and it never goes completely dark. So I think the first day of the eclipse is usually very interesting to watch. And I go through, I don't explain a lot. I just go through a few details to show you that it is impossible that it goes dark due to an eclipse. And the first thing is, this is SDO eclipse season. So this was from February 14th, 2017. And I think the sun started going dark at 7:13 UTC. So this is during when it's still going dark. And we see here two images. One is the X-ray image, 9.4 nanometers, and the other one is an ultraviolet wavelength image, the 21.1. And in the first one, first of all, the Earth's atmosphere absorbs X-rays. So we cannot have the SDO detectors seeing part of the sun through the Earth's atmosphere in the X-ray image. So the image we would get in X-rays is what the sun would actually look like with everything in the whole Earth covering whatever part it could cover if this was due to an eclipse, okay? Now, it is possible that some of the ultraviolet light gets through the atmosphere. And if that was the case, then the SDO detector should be able to see a larger part of the sun because some of it is now going through the atmosphere. So these images are both from 7/16 at the same time. But notice that the part of the sun you see in X-rays is larger than the part you see in the ultraviolet image. And that's just not possible. It should be the other way around. If we're going to say this is an eclipse and SDO detector is just seeing part of the Earth through the Earth's atmosphere. So we're getting contrary evidence here. And that's one of the reasons why I say this cannot be due to an eclipse. And then I go on and I actually look at the timestamp, which is in green. And the timestamp gives the exact timestamp for the X-ray image, which is the one on the left, I think is 7/16/23. And the one for the 21.1, the ultraviolet image, is 7/16/21. That's 2 seconds before. So if we look purely at timestamps, the sun is getting progressively darker. So if it's getting progressively darker and the purple image is before the green image, then we should see more of the sun in the purple image. But it's the other way around. So that's 2 reasons why this cannot be an eclipse. What this tells me is that the sun is actually going dark, and it's going dark at different rates for different wavelengths.
So this is one of the main reasons, I'm sorry to interrupt you, but this is one of the main reasons of you discovering this. This is one of the main reasons why that YouTube channel that nobody respects, Astronomy Live, this is one of the main reasons why he went after you.
That's right. This, don't forget, Scott, this is like NASA's baby.
Oh, yeah.
Every year, they have the eclipse season, and they advertise the eclipse season as if their lives depend on it. And obviously, they have a reason for that. So when I started saying that the SDO eclipse season is the sun actually going dark, that's when they started coming after me. Because I am directly challenging NASA by saying this. But the truth is, it's impossible that this is an eclipse. And also, this started my whole thinking about the fact that the sun has to be electrical in nature. Because only an electrical sun can go dark like this. And it cannot be having fusion reactions in the center, in its core, because then there would be light coming out of it all the time. It would be impossible for the sun to go dark if that was what was powering the sun. So this was almost like the beginning of where I started realizing, but wait a minute, the sun is not what we've been told it is. That's impossible. And then I started looking into the electrical theory, and I never bought into it completely. I still think that the sun still has fusion reactions, but on its surface, not in its core. Okay, so
well, let me ask you a few questions real quick. You know, based on this, the Solar Dynamic Observatory, the SDO eclipse, what are they saying, the opposition? What are they saying is creating this situation with this eclipse? How do they define it?
They're just saying that the Earth is getting in the way of SDO's view of the sun. So, and the Earth would look very large, and in comparison with the sun, because at that point the detector, well, the detector would actually just go behind the sun. I have written some articles about this where I explain that. And so, I mean, the detector goes behind the Earth at that time, and so its view of the sun is blocked, basically. And because of its orbit, this would happen twice a year. And Astronomy Lives, they can say, they can predict it through a long calculation. I actually looked back until 2011. And I could predict it as well just looking at the period. It's got a 178-day period, and every time the season starts every year, it's always 4 days early. So you don't need a long calculation. You can just look back and see. And to me, that has to be due to an object that has some kind of orbit that brings it close to the sun and causes the surface of the sun to go dark. And so that's what I've been saying from the beginning. I haven't changed that. There was one thing that I made a mistake about, which was the 182.5-day cycle. I know I made a mistake with that, but it doesn't, because I didn't understand the whole thing. You know that I'm not an astronomer at the beginning when I started speaking about this. But that small fact does not change that these images are, and what is happening, and this is just 2 examples. Don't forget, this happens at the beginning of every single cycle. And if you look at the images for every single wavelength, you come out with exactly the same conclusion. It is impossible that this progressive darkness across the sun is caused by an eclipse. It's just impossible.
So let's go back for just 1 minute here, because I want everyone to fully understand something, and the doctor just went through it, but I'm going to expose it a little bit more.
Mm-hmm.
So during this SDO eclipse season, you were able to prove that this is not happening by any means and dealing with the Earth. This is not the little tiny Earth compared to the massive size of the sun. This is not the Earth getting in the way of the SDO camera system and detectors to eclipse the entire sun. So once again, this is something that NASA has been covering up for a long period of time. Nobody was really talking about it until the doctor discovered and observed and produced reports on this. Then, at this point in time, Astronomy Live takes it upon himself to, well, basically dispute what she's saying. Then NASA comes out, and now they're talking about the SDO eclipse season. I mean, they publicize it now like it's some big event. So they're trying to overshadow what she has discovered. And at this point in time, this is when Astronomy Live began his vicious attacks against the doctor. Now, as she just said, he did a video on this SDO eclipse. He had to confuse and divert everyone watching his videos, if anybody even does, but he had to use this huge, long mathematical equation to make it look like he was Mr. Super Smart Brainiac. But in actuality, it doesn't take a massive equation to prove this. Mm-hmm. And then, because the doctor made a slight miscalculation by, what was it, like a few days or something, or is that what?
No, I didn't make a mistake with that. What I said was, well, it should happen every 182.5 days. And I didn't realize that at the time that wasn't correct. It should happen, you shouldn't add a half a day, let's say it. And I've put, I think Chris has an article up where I explain that. So because I wrote many articles about the SDO eclipse, and from the moment I saw it, I didn't believe that it could be due to an eclipse. And one of the reasons why is, if you look at the structures at the edge of the darkness, they always complete. They never partially covered. So if you look at a filament there or a little piece of the sun, it always looks complete to its edge. So it doesn't look like half of it has been covered, say. And so I thought, but this is impossible. If the Earth was covering the structures on the sun, we would see some that are cut off halfway through. And we never see that. They're always complete. It's like little pieces of the sun are actually going dark or not going dark. And then a few seconds later, those ones will go dark as the sun progresses. But the structures go dark completely. You never see a small blob there going half dark or it's which we would expect if it was covered by the Earth. No, they either on or they off. That's what I see. That's what I saw from the beginning. But NASA, I think, doesn't want people to realize that the sun can go dark because it changes everything, like it changed everything for me when I saw what was happening. And then I investigated this and further and further. And for me, this about comparing images like this is irrefutable. I mean, I spoke to an astronomer at the university where I work, and he still could come out with some excuses. He said to me, well, it could be that NASA is getting their timestamps wrong. And I said, how can NASA be getting their timestamps wrong on all wavelengths since 2011, twice a year? It's impossible. They're not getting their timestamps wrong. But then there is one other thing which I talk about down there, and that is how you would expect the corona to be covered, but the corona is never covered. The corona actually shrinks as the sun gets progressively darker. And that he refused to talk to me about because it's irrefutable. In fact, we had a long conversation. I had a long conversation with him. I talked to him about this, but he said, yeah, we're going to talk, but we're not going to talk about what happens with the corona.
So, well, what's the sense of having the conversation then? See, exactly. This is why, this is, ladies and gentlemen, I've said this before. I'll say it again. You know, besides the doctor, I don't trust any astronomer like a professional. I don't trust any professional astrophysicist. Okay. I don't trust any of these people. They are all under the thumb of NASA. Okay. I don't care which way you slice the pie. They're not going to say anything bad against their big daddy. Okay, because at one point in time, their university or wherever they work as a professional astronomer, they are going to need the funding, the money. And if they start bad-mouthing NASA and questioning NASA, well, they're going to be ousted. They're not going to have a job. And for them, it's professional suicide. Case closed.
Mm-hmm. Yeah, that's right, Scott.
I don't trust any of them. I don't trust any of them at all. Now, these four images here, this is what you were just referring to before I had to go off on the professional astronomers. You know, I mean, that just really goes to show you, you know, how the gentleman that you were referring to, he was a longtime friend of yours, correct? The astronomer? Doctor, did we lose you?
I lost you for a moment. I think you probably lost me as well. What did you say?
Now, what I was saying was the astronomer that you were talking to. He's a longtime friend of yours, isn't he? You've known him for quite a long time.
Yeah, well, yes, we've been known each other for quite a few years. Yes. He's got an office close to my office at the university.
Oh, there's the key.
Yeah.
He works at the same university, so he's an astronomy professor.
Yes, he is.
Oh, well, we can sit down and we can have coffee, but we cannot discuss this.
Mm.
No, my.
Yeah, I also sent him pictures of the blue-brown brown dwarf, and his answer was, I cannot believe that only one person is observing this. So then I sent him copies of YouTube videos. I said, no, we're not the only ones observing it. There are lots of people observing it with their naked eye. And then he never responded to that one.
Well, listen, I have an update for everyone. So listen and listen clearly, ladies and gentlemen. These idiotic trolls were making videos using my photographs of this big blue striped object. This one idiot, and I have to call this guy a complete garbage pail idiot, lives over in the UK, has a trolling YouTube channel. We've already had one of his channels shut down. But then, you know, in a week, he's right back up producing the same crap. He did a video shortly after I exposed this large blue striped object, and then we did our live stream about it, and then it was captured again. They took my photographs off of screen sharing, or not screen sharing, screen capturing from their piss poor computers. And they said at first they sent the photographs off to a forensic photographer. Then that story changed, and they said they were using a computer program that is on the internet called photo forensics. And they said that photo forensics, after analyzing my photographs of this big blue object, they said that it was a dirty towel with bacteria on it. So, you know, I laughed that off. I thought that was pretty stupid. And if you're trying to convince somebody of something, how could you even begin to make someone believe that that object was a blue dirty towel with bacteria on it magnified? That was the stupidest thing that I've ever heard. So I decided to look up this photo forensic website. And I wanted to see how sophisticated it was. Well, I loaded 10 photographs that I took of this blue, you know, the big blue striped substellar object, and I ran the scan. And ladies and gentlemen, I used the same photographs that this stupid scumbag troll over there in the UK, I used the same photographs that he used in his diagnostics. And when the results came back, it didn't say anything about bacteria, and it sure as hell didn't say anything about a blue, dirty towel. And what it actually gave me was some very important information. So once again, ladies and gentlemen, it just goes to show you that these people are lying. They're lying through their teeth. They are the scum and the rot of the earth. And eventually, ladies and gentlemen, the earth will cleanse itself, and I just hope she does a good job and she sweeps all of this garbage right out the door, because that's exactly what these people are. All of them are complete garbage. So now, because of these idiots, I have myself a new tool, and I will be using photo forensics to analyze a lot more of these photographs that I have coming in from you guys, the subscribers, the viewers, photographs I take myself. Thank you, the troll community. Thank you very, very much for doing something so idiotic, but giving me another tool to prove that what we are seeing, what we are experiencing, is true. Thank you. That will be the only time you ever hear my words. Thank you. in reference to these dirt bags. But anyways, I just wanted to let everybody know that.
Good.
Photo forensics. Yeah.
Okay, so maybe I should go on explaining what we see here. So on the left, you see the corona. On the first image on the left, you see how large that corona is. In the second image, you compare the same area on both images, and you see that the corona is not as large in the second image. If we could zoom right into that image right at the top, you would also be able to see that the sun, the top edge of the sun is still visible. Can you zoom into that image?
Oh, I could zoom, baby. I could zoom all you want. How about that?
Thank you. That's good. Okay, it's a little bit faint, but there's a faint line right at the top there where you see darkness below. Right at the top of the sun. Yeah, you see that line there. So the sun is going dark in that region, but there's an area behind it that's not yet dark. That's why there's an edge to it. And that clearly shows, if you compare with the image next to it, that that portion of the sun is now going dark. This is how the sun goes dark. You see the difference between that? There it's not dark, you see the edge, there's no corona, but you see that edge. And then in the next image, you still see faintly, you see that edge, and then you see the region below is dark. The sun's going dark. That's how it starts the first day. And then if you compare the corona from side to side, you see that the corona is small in that area where the blue arrow is than it is in the image on the left.
Where did it
go?
Where did it go?
Yeah. Yeah, right. You see.
Oh, so, wait a minute. You know what? That's the Earth. That's the Earth. The Earth did this. The little teeny tiny little Earth, it did this to a massive object in our solar system that we refer to as the sun, which is approximately 864,000 miles in diameter. The little Earth did this.
Yeah.
All righty.
Yeah, so you see the corona shrinks as this is what I'm trying to show is the corona gets smaller from image to image as the darkness across the sun progresses, because the corona is being affected when the sun is not emitting light from that region. The corona in the region ahead of that is already shrinking, getting smaller and darker. And you see that as we compare. So you compare the first left image with the image on the right of that, and you see the corona where that blue arrow is smaller there than it is in the left image. And then again, if we compare the image on the right in the first row with the image just before that, again in the same region where we have the blue arrow, just look at it. Look, compare the size of the corona in that specific region between the two images. You see the corona is much smaller. It's not being covered. If it was covered, we get a straight line right through the corona, and the corona would seem to continue behind the black line.
Mm-hmm. Exactly.
But that's not what we see. We see the corona shrinking as the darkness progresses. In the last image, you see again, it's lower down, but again, the corona is shrinking. And you see it's actually angles itself so that it's very thin towards the edge of the darkness.
Yeah, you know, and this doesn't even, I'm going to zoom in on this because this doesn't even look like any type of eclipse. Like you said, you can simply see the progression of the darkness moving downward from this being fully illuminated, if you follow my cursor. So, ladies and gentlemen, NASA and the geek from Astronomy Live, they want you to believe that this is the Earth. This is the Earth causing this. What do these, they must think that we're all completely stupid.
Yeah, that's why NASA advertises every year to make sure that people are convinced that this is an eclipse. But they cannot convince me. I'm not convinced. I am, in fact, I am totally convinced of the opposite. I know for a fact, and this with the corona is irrefutable proof. No amount of timestamp messing up, nothing can refute the fact that the corona is shrinking, and that is impossible if this is an eclipse. It's impossible.
You want to hear something that's bad? If with the whole time stamp issue, if NASA can't get time stamps correct, then how are they putting supposedly a man on the moon? How are they putting, astronauts into orbit? How are they doing all of these absolutely fantastic scientific things, but they can't get a timestamp right? I find that very hard to believe with the detail that a lot of the NASA geeks and the NASA fanboys like Astronomy Live, I just don't see the timestamp being a factor in these lies. Because the way you're explaining this and the photographs that we're seeing right now clearly do show the sun going dark all by its little self.
That's right.
Well, NASA fanboy.
Yes. That's right. This is why he came after me. This is the reason why. And I can't change what I see. I have to speak the truth, Scott. This is the way it is.
You speak it.
The sun is going dark.
You speak it. You speak the truth. That's what we're all here for.
Thanks, Scott. Okay, so then I explain. I know I don't have a lot of images here, but what I do explain is, so there are no thermonuclear reactions in the sun's core. So the only thermonuclear reactions possible will be on the sun's surface. But then, well, we are told that we need very high temperatures, and the temperature on the surface is not that high. But then when you realize that the sun has to be electrical in nature, then you have electrical input into the fusion reactions. And that means we can have cold fusion, or what's called low energy nuclear reactions. So I think that's actually what's powering the sun. What is happening is on its surface, we are getting fusion reactions, but they are happening at a much lower temperature because the sun is an electrical star. It's powered like a battery. This is my own theory. This is, to me, what explains what I see happening in the universe. I know that a lot of people that look at the electrical theory think of it as being powered by currents from the outside. I don't see that as being happening because stars age. They turn into white dwarf stars, brown dwarf stars, and brown dwarfs, which are stellar remnants. So in order for stars to age, they have to run out of energy. So I see stars as having electrical potential energy like a battery. And therefore, they're producing an electric field, and this electrical field is ionizing the particles, producing the plasma inside the photosphere. The photosphere, like I said before, is 500 kilometers deep or 310 miles deep. And then the magnetic field interactions are causing the sunspots. And then I show.
Good. I'm right here with you. I'm right here with you.
Okay. What happened?
Oh, I thought we were done with the report.
No, not yet.
Oh, let me get it back up there.
Sorry.
Oops.
Yeah, I still have a
hit the wrong
picture
button.
showing what's actually creating the magnetic field loops coming out of sunspots.
Let me just pull that up.
There, I just wanted to explain about it's cold fusion that's powering the sun. Well, actually, it's the electric potential energy of the sun that's powering everything, but we are getting fusion reactions on the surface, and those together with the electric field are producing the light and that we see on the sun. So, okay, so we can move down. So you see that is what's called a solenoid. It's a wire formed into loops, and it generates a magnetic field that looks just like that of a bar magnet. And if you look at those loops on the top, they look just like the loops that come out of the surface of the sun and through the sunspots, right? So what I'm saying is we must have the same sort of thing happening inside the photosphere, that 500-kilometer deep area of the sun. And so if we move down, I actually drew a diagram to see what I think is happening. So I think the sun is powered by an electric field and or electric potential energy, and the star is rotating. Because it's rotating and it's a gas, well, it's actually a plasma because the electrons have been stripped off the nuclei because of the high electric field. And the interactions cause heat, cause fusion to happen, and so on. But what it develops into is this turbulent movement of the plasma. So you form sort of eddies in it, or tornadoes. The same thing happens on the Earth. We also get tornadoes. We get storms. So we can say that what's happening in the photosphere is storms. And they form these eddies or tornadoes. And then because the particles are ionized, they form electrical currents that then move in this looped fashion, so it looks like a solenoid, and that generates the magnetic fields that we then see poking out of the sunspots. And so that's what I showed there. And then I go on and I just explain a little bit about the fact. Now, the conventional theory explains that what's keeping the sun from collapsing under the gravitational field is the fact that it's got thermonuclear reactions pushing everything outwards. But these thermonuclear reactions we can now see are not happening. So what does that tell us? That tells us that the sun is not collapsing gravitationally for another reason. And to me, what I see here is a bit more evidence with what I discovered by studying the brown dwarf stars and their density, is that the sun's electric field generates a gravitational field. So the gravitational field, and therefore the mass, because gravitational field is supposed to be a direct construct due to mass, is not intrinsic to the matter that the sun is made out of, but it is generated as a function of the electric field or the electric potential energy of the sun. And this is what I've seen from observing the brown dwarf stars and comparing them to white dwarf stars, which they must have gone through at some stage, that evolutionary stage. So I see here again the same thing, that it seems that mass and the gravitational field are not intrinsic properties of matter. They are generated by electric fields. And to me, this changes everything about the universe, absolutely everything. So I just want to finish with that.
Yeah, and we don't want to change anything that all of these old scientists and astrophysicists and astronomers have noted down into the textbooks. We don't want to update that. We don't want everybody to know the truth. We want them to stick to the old hat information that's been out there for a long, long time. Yeah. Well, that's not going to happen, ladies and gentlemen, because the doctor is onto something. She's a very smart, intelligent woman. And, you know, what really, really gets me is when you start talking about this cold fusion. And they don't want to hear anything that has to do with cold fusion. You want to tell everybody why?
Well, cold fusion will lead to basically very cheap energy.
Did you hear that, ladies and gentlemen? Cheap energy. They want to keep paying the electric bill.
That's right. So what they have is fission. That's why they use the nuclear power plants use fission. Fission is very expensive. It's very expensive for the whole planet. First of all, it's very expensive to construct the vessels that hold the reactor vessels, because they have to contain the fuel. And then what we have is what's left over. The rods are still emitting a lot of radiation for thousands of years still, and it has to go somewhere. It's very dangerous. It potentially can destroy the planet, and I believe Fukushima will eventually destroy the planet if no one does anything about it, because the radiation keeps coming out, and it keeps accumulating on this planet, and it's destroying the Pacific Ocean. It will destroy every ocean on Earth eventually. It may take 20, 40, or 50 years, but eventually all life on Earth will end because of Fukushima. And this is why fission is so expensive. And it's very expensive to build the reactors, like I said. Now, cold fusion is actually very cheap. Once you start producing reactors that are able to produce energy, and it's fusion, it's clean energy, at room temperature, everybody could have one in their car or in their house. You never actually need to put much fuel in it. Very little fuel will produce a lot of energy. So it becomes very cheap to run these fusion reactors. And they don't want us to have that. They want us to go on being dependent on gas. And this liquid gold that comes out, the whole economy runs on this liquid gold. And they don't even tell you that whenever they pump the oil out, that the gas wells fill up again. The Earth seems to actually produce it. And so they want us to believe that we're going to run out of oil so they can keep the prices up, so they can make a lot of money out of us. So they don't want us to have clean energy. They don't want us to have cheap energy. They want to keep us as slaves, and that's the way I see it.
Well, that changes everything. You do realize that. I mean, I know you do, but ladies and gentlemen, you do realize that this theory of cold fusion upsets the apple cart. This empties the bank accounts of the elite, the oil moguls all around the world. Free energy, man. Free energy, or at least an energy source that would be more cost effective for all of us. But they have to keep you down. That's the main goal. They have to keep you down. Absolutely ridiculous. You know, I never heard of cold fusion before until you brought it up to me. And it's a very, very touchy subject. And when you start dealing with the fact of the matter is you can bring very inexpensive energy for the entire world, modernizing some countries and some areas. They don't want that, ladies and gentlemen. They don't want it. You know, we're like a bunch of puppets, and they are the puppeteers. They want to keep us dangling in the dark, and that's just not going to happen. You know, I just got an email from our buddy down there in Australia, Prep Aussie, and I sent him a link to the live stream, and hopefully he gets the link and steps in with us.
Okay.
We've been trying to get together to bring some information from him, because he's doing a fantastic job in his observations, and what he does with these photographs by bringing out these objects in these photographs is just absolutely amazing. What I've pulled up right here is the current view. What is this button here? I'm not used to using. Oh, that zooms it in. Well, look at that. Look at that. What we're looking at here, ladies and gentlemen, is a current view from the SDO. What wavelength is this in? This is in.
I think this is the 30.4 nanometer.
Right. Yeah. And ladies and gentlemen, you know, this is what we were looking at early on. We were looking at this very large sunspot right here as it was rolling from the left side of the sun coming off. It is just above the sun's equator, and there is activity coming from this sunspot. You can see the ejection right there. Matter of fact, can I zoom in? No, I can't zoom anymore. That's about all I can go on this program.
Yeah. But you could see that the solar flare, you can see that light there. So that's the solar flare. And then you can see a CME being ejected, but slightly downwards. Yeah. So you can see exactly what I was talking about happening right there. It's amazing.
Yeah, and there were, you know, some other not so credible YouTube channels, such as that Jake WTF Sky, the Grand Solar Minimum YouTube channels that they've put together simply to try and discredit what the doctor is showing you. Okay, we're not seeing these signs of Grand Solar Minimum. I mean, the sun has plenty of activity right now. According to the doctor, we're what, 3 years away from the possibilities of Grand Solar Minimum?
Yes. It's sometimes the cycle can be up to 14 years long, but it's on average 11 years. So we had the solar, the last solar minimum, I think, was in 2009 or 10, I'm not sure, but the maximum was in 2014. So I think we might have the solar minimum in 2020. So yeah.
Now let me ask you something. I just watched a report the other day, 2 days ago, by BP Earthwatch, and he was going over some information that was just released, data that he was looking for to confirm the possibilities of Grand Solar Minimum.
Yes.
But here's my question. Are we able to trust this data? I mean, I've seen so much skewing of data coming from NASA and NOAA and the USGS. My question is, can we really trust it? Can they make us believe that we're going towards this Grand Solar Minimum by skewing the data?
Yeah, the thing is, the solar minimum is based on the fact that the sun is getting weaker. So if the sun is getting weaker, then cosmic radiation coming from outside the solar system, it should be easier for it to get in. So if we have gamma ray bursts coming from, say, another galaxy and hitting the solar system, it's easier for it to get in. And gamma ray bursts will affect our ionosphere, our magnetosphere, much like intense solar flares. So they energize the solar wind particles, and they do things like CMEs can do to our magnetosphere. So they can be dangerous, and the sun going weak, I suppose, would allow more cosmic radiation to get in. That is true. But I think BP there associated it with the earthquakes that are happening. And I'm not saying that we cannot get earthquakes because of gamma ray bursts. But the one he was talking about was the one in 2004, I think. And the gamma ray burst arrived on the 27th, but the earthquake in Indonesia was on the 26th, so the day before. So that couldn't have been caused by that gamma ray burst. But the thing is, what I see happening, I mean, I don't discount the fact that the sun is getting weaker. I believe the sun is getting weaker. I believe it's getting weaker because it's being drained of energy because of all the brown dwarf stars we have in the solar system. But that doesn't mean the Earth will be cooling down. And it is true that cosmic radiation can cause more clouds and cause certain areas on Earth to cool down. The same thing can happen with volcanic activity. But what's causing the Earth to cool down the most in winter is geoengineering, because it's causing artificial cloud cover. So even though we are getting hit by more cosmic radiation, and that causes nucleation in the atmosphere, it's not like we're getting constantly hit to the point that the Earth would cool down as much as geoengineering is doing. Cannot discount what geoengineering is doing. It's causing some of what's happening, most of what's happening with the weather. But the other thing that is happening is that the Earth is getting hit by a lot of radiation. A lot of it is coming from the sun, and the solar particles are getting energized by the fact that the sun is interacting with these other objects. These other objects have magnetic fields that affect the Earth's magnetic field. They are causing currents inside the magma, and the Earth is warming up from the inside, from the core. The same thing is happening with all other planets in the solar system. And they've been doing so since the 1970s. The 1970s was way before any of the solar minimums where we've seen that, okay, it's a lot worse than it was before. But what was causing then the planets to warm up then? It couldn't have been anything to do with the sun, because the sun was normal then. So there's no evidence for this grand solar minimum when you think of it like that. And then the TSI, I think they are screwing some of the data, the TSI data. But I mean, if that's the case, if we use the TSI from the University of Colorado, it's been the same since the 16th century. So there is no 200-year cycle evidence. So if anybody says there is a 200-year cycle, where's the evidence? I don't see any evidence. And if I don't see any evidence, then I'm sorry, I have to discount it.
Exactly. Where did they document that evidence? Where is it?
I mean, I just showed you the evidence for the fact that the sun is not having thermonuclear reactions from the center. The evidence is in the SDO images in what happens to the corona. I have evidence. I showed you the evidence.
Absolutely.
Then if you want to come up with a theory that the sun is having thermonuclear reactions, or, you know, for a 200-year cycle, you have to show evidence.
I agree. I agree wholeheartedly. I want to do I wanted to get your quick observation on what we're seeing here. Let me see if I could see it a little bit better in this. Oh, let's go to another one here. Now, paying attention to this region where this sunspot was, because the sunspot is no longer, but I want your observation on this burst of energy right there.
Yeah, you see, what we see there, that is the sunspot. It's just we are looking at the corona here. So this is another layer above the photosphere. So in the photosphere, if we were to look at the photosphere, we would see those holes. But if we look at it in, this is the 19.3 nanometer, what we're seeing is a layer above the photosphere. It's actually a layer in the corona. So we still see the plasma loops, though, coming up through the corona. The particles are flowing along those looping lines, and we're getting reconnections. And when we're getting reconnections, we see that light coming out of it. And we see the particles in the plasma being accelerated to extremely high speeds because of that release of energy. And that's what we see there, is that release, that huge explosion of a solar flare and a CME type event happening. There we are.
But this was a good example of what we're watching right now. Your report in detail with your diagrams was fantastic. And we're actually seeing in real life, in real time, on this 48-hour loop from the SDO, we're seeing exactly what the doctor just explained.
Yes.
So this is absolutely perfect timing. That's why I asked if she could put together a report on these sunspots, because we often hear about them, but we don't understand them. And we don't understand the mechanics or the dynamics of these sunspots and what they can do and what they produce. I think she's done one hell of a job quickly explaining that situation. And now we're actually getting to see what is occurring. So this was absolutely fantastic. I'm going to flip over to another image real quick. And take another real close look. We're just zipping through a couple of these images just to see what we see.
Okay. I think they're amazing. It is amazing to see the sun in action, to see that energy coming out of those. And that's because of the intense magnetic field. The magnetic field lines are so close that we have, it's easy for them to make these reconnections. And then there's this release of energy, and you see the light coming out. There we are. It's like, it's beautiful. And it's intense, and the light, it's amazing. I enjoy watching these.
Yeah, this is one of my favorite colors right here, aqua blue.
Yes.
Pretty close to the same color in my eyes.
Yeah.
Yeah, this is amazing, and it is beautiful to look at this, you know. And I hate myself for saying this right now, but I guess, you know, it's a thank you to NASA so we can see these images. Oh, I can't even say that. Oh my God.
Don't forget that the U.S. taxpayers pay for this.
Oh, thank you for reminding me of that. Well, you know what? You are absolutely true. Absolutely 100% true. You know, ladies and gentlemen, I don't know if any of you know, but the big NASA jumbo jet airplane that they refer to as Sophia, that has the big space telescope in the back of it with all of those billions of dollars worth of equipment, has been flying around the West Coast now for 3 days. Chris Potter was doing a report earlier this morning on our live stream pertaining to this. And then the YouTube channel, Mr. MMBB333, fantastic YouTube channel. I love that guy. He's so smart, great observations. He does a lot of reporting on the UV, but he was reporting earlier that the big Sophia NASA jumbo jet has been traveling back and forth all along the West Coast over California. And it seems to be that they are interested in the sunset. Ladies and gentlemen, did you hear what I just said? That NASA is using their big airplane space telescope, Sophia, to record, photograph and analyze the sunset at 39,000 feet over the west coast of the United States. Ladies and gentlemen, did you just hear what I said?
Mm-hmm.
Yeah. All righty then. So
Yeah.
people really want us to believe that nothing's wrong, nothing's happening, everything is just peachy. It's just fine. Well, you're not fooling me. You're not fooling the doctor. And the majority of the people that subscribe to my YouTube channels, you're not fooling us either. You know.
Yeah.
But this is a pretty amazing. It is a pretty amazing situation whenever you're able to take a look at these images and see this in action. Yeah. I wanted to see what the this is the I think this is the
yeah. But going back to the sunset, I think you've been recording very red sunsets, and that tells me that there are objects near the Earth that are emitting red light, and that's possibly what they are looking at as well. They want to know exactly where these objects are, what radiation they are emitting, because they have all kinds of detectors, I think, on that plane.
Oh, and yeah.
They go above the haze that geoengineering places above our heads, so we cannot see clearly. But we can still see the red sunsets, which are not normal.
Yeah, I mean, just the other day, I went to leave, and it was, I think it was around 8 p.m. And I went to get in my car, and all of my neighbors were standing in the middle of the street, and they're all pointing up to the sky. And I immediately stopped, and I'm like, oh, what are they looking at? Maybe what are they seeing? Because they're all pointing. Yeah. And they're pointing exactly due west. And the sun had already set. And the whole entire sky above us, and in front of us was completely illuminated in this bright magenta, purple, and pink. Everybody was standing there looking up. Now, none of my neighbors know what I do and what I research and investigate. And I did stand there and I did take a photograph. I took a photograph of what was occurring. And matter of fact, let me share that photograph with you real quick. My computer's been acting up a little bit here, but let me just move over here real quick and I'll share this photograph with you so you can see it. Just give me a second. I'll pull the information up. Because the photograph was just absolutely amazing. It was breathtaking.
It was amazing. I couldn't believe it when you showed it to me. It's just, but yeah, that was some of, yeah.
That was about quarter after eight, okay. 8:15, something like that.
This is what got me into this research, was looking up at the sky and seeing things like that which were not normal. And I mean, it wasn't as dramatic then last year, but it was still so strange to me that I just had to look into it.
Oh, you know what? One of my moderators, Heidi, she is from Australia, and her and Dark Angel, they do a fantastic job in the live chat moderating. And she just sent me an email, and she was just wondering if you might have a little bit of knowledge on, it says just to ask you if bicarb soda soaks up radiation. She said that she's heard that drillers use it when mining for uranium. She's just kind of curious if you know something about this, and I'll be pretty impressed if you do.
Well, I know bicarb is a base and it absorbs acidity. So whenever you have a problem with your body, and whether it's from radiation or heavy metals, what happens is your body starts producing more acidity than normal. And cancer is also easier to grow in your body if your body is acidic. I know that. So I know bicarb would counteract those. Whether it will absorb radiation, that I am not sure of. But it is helpful for the body in many ways, that I can tell you.
Okay, I finally got the photograph up, and I hope everybody could see that.
Wow.
Wow, look at that.
Oh my goodness, that is just unbelievable. That is the clouds. They are illuminated from the top with those colors. You realize that, Scott?
Yeah.
This is not aurora. This is not aurora. This is clouds being illuminated by red and magenta light. And the only thing I can say is there has to be a star emitting this light outside the Earth's atmosphere. That's the only possibility.
This is what my neighbors this is what my neighbors were looking at. That's facing exactly due west.
Unbelievable.
Everybody sees that, right? Do you all see this photograph? Everybody, ladies and gentlemen, somebody throw me a couple of yes or no's. Do you all see this photograph I'm showing right now on your screen?
Yes.
Okay. Is that
Alan.
Aussie?
It is.
My goodness, brother, how are you?
Good, good.
We were just looking at a photograph that I took this photograph a few days ago, and all of my neighbors were standing out in the middle of the street, and they were all pointing, look up in the sky. It's a bird. It's a plane. All of the sky is pink and purple. And this was about, I think this was about 8:15, and I was leaving my house, and I took a photograph of this, and they were all pretty freaked out. And as you could even see close up, the street lights. You look right here, the street lights were already on.
Yeah.
The street lights had come on. They all have a photo sensor, a light sensor, which turns them on and off. And they had already come on, and then out of nowhere, the sky turned purple, and this huge pink cloud.
Wow.
And you could even see it is illuminating on the cars. Look at the cars.
What?
Amazing.
Look, you could even see, well, that might be the street light, this small illumination here.
Yeah.
But, like I said, my neighbors don't know what I do as far as research, but they were all standing in the streets right behind me down towards the left. They were all standing there. They were all standing there looking up. Their mouths were hanging open. They were like, wow, look at this. You know, pretty cool picture, though.
Yeah.
Can you hear me?
Yep, I can hear you. Just let me get out of here real quick and back over to our main screen.
Okay.
Okay, there we go, brother. I can hear you. You might need to speak up just a little bit, or I could even turn up your mic, I think.
How's that better?
What's happening, brother? How are you?
Very good, mate. Very good. Look, that picture you just showed.
The picture I just showed?
Is this picture, is it not, that you just sent to me yesterday? Yeah,
exactly.
That's that picture, is it not?
That's the big pink picture.
Right. Just, you can see my screen then, yeah?
You'll have to click on your little square icon in the lower right to share your screen. after you screen share.
Right, okay. The little icon in where, mate?
Oops.
Oh, okay, on the, I'm not very, screen share, there we go.
And then you'll move down to your picture that you see in the square, and you'll click on your picture, and then it will give you that tunnel vision look of the screen, and then you'll click on the screen that you actually want to share.
Okay.
There you go. Oh, you had it. Did you find something in that picture?
Yeah, well, that's what I'm going to show you.
Oh, boy.
Can you see my screen now or not?
Yes.
Oh, there we go.
Hold on one second.
Is that working now?
There
Tunnel
you
vision.
go. Yeah, tunnel vision. Now go down and click on the picture icon that you want to show.
Okay. Can you see that now?
There you go, buddy.
Right, is it working now?
Yes.
Yes, we can see your file folders.
Yeah.
Okay.
There you go.
Right, beautiful.
Mm-hmm.
You can all see that, yeah?
Yes.
Yep, we could see it.
What I don't understand is, and we've spoken about this before, Scott, is how come I'm seeing stuff? Okay. So I just want you to watch. Are you looking at the screen?
Yes.
Can you see the picture? How come every single one of you missed the big planet here?
I actually did see it look like there was an object there, a circular object behind the cyan cloud there. Is that what you're talking about?
Yep, watch this.
Oh, it looks like there's an object there. I actually saw it, but I wasn't sure, so I didn't say anything. I wanted to go back and look at the image first. Yeah, it's.
Yeah, I haven't examined the photograph other than sending it off to you.
I noticed that. I did.
Oh my dear God!
It's
Can
huge.
you zoom in on that?
It's not a cloud, guys.
No, yeah, I agree with you. I didn't think it was, but I thought, well, I can't quite see well enough. I need to go and examine that picture again. But yeah, but now that you're saying it, yeah, I did see that.
Oh dear God.
Yeah, there's an object in the sky there. And it's
that's my God.
That's the source of the light, because we're seeing it through the clouds. That object is emitting this light.
Oh my, I almost dropped an F-bomb while we're live on the air.
Yeah, that's
ladies and gentlemen,
amazing.
I hope that you're seeing this. I hope that you are seeing this.
Yeah.
Are you able to expand your screen a little bit?
For me?
Are you able to zoom your screen in a little bit?
Yeah, hang on a second. I lose a bit of pixelation when I do that. But I think
that's good.
It should be pretty good at your end.
Oh my God.
Uh-huh.
I can't understand how everybody missed it.
Yeah, well, you see, you have special eyes. That's why. I cannot say that I actually missed it. I did see it, but maybe I wasn't confident enough in what I was seeing to mention it.
Holy shit.
Yeah. But you're absolutely right. That's the object.
My heart's beating real fast right now. And I know it's not from the Red Bull that I just drank.
No.
It's there, guys. It's 100% there. It's not a fake.
Yeah,
Oh.
you're right. It's definitely something there. Oh my goodness. Here's the brown dwarf close to the Earth. Now this is at sunset. You said what time was it?
About 8:15.
Scott?
8:15 p.m.
And it should be nighttime by then, right?
Well, it starts. It's the sun's already setting. It's still illuminated outside, but during this time of year, going from June to July, the conditions will be still lit up. But we don't get skies like this. This isn't something that you normally see in the northern hemisphere.
So this is on the side of the Earth. It's not behind it. It's to,
that is exactly
to the side.
Due west. That is exactly
due west. And isn't that where we saw those particles coming from and going into through the bow shock into the magnetosheath?
Pretty much, yes.
Yes. So this may be the source.
Do you think that this is a possibility that is a planet that has been brought in, or do you feel that is a light source, that is a brown dwarf? I think
that's a light source. I think that's definitely a light source. There has to be a light source to produce this kind of coloring in the clouds. So this object must be illuminating the clouds. I don't think it's a planet, because if that was a planet, we would have another light source. I mean, it's very difficult to see the moon through clouds when there's still light in the sky, isn't it?
Exactly.
So I think this object is emitting light.
Oh my Lord.
Yeah, so it's a star. It's not a planet. It's
Look
one
at
of these,
that.
Yeah.
I am totally blown away by that.
It's amazing. I'm glad Alan came along. I must say that I was looking at that object when you were I said, oh my goodness, is that an object there in the sky? But I wasn't sure, so I didn't say anything. I should have. It's amazing. Yeah. Wow.
Now what I'll try and do is brighten it up a bit. Sharpen it up a bit.
Oh my God.
Yeah.
You can see from the density that see the density here. That's the heat that's being, well, that's on that picture.
Yeah.
And the rest of it is heat, obviously, but it's, not as hot as that, because whatever's reflecting off it, I guess, the sun.
Yeah, I think these are brown dwarf stars. Don't forget they have envelopes around them. All brown dwarf stars have gaseous envelopes. So it's possible that they are brighter on one side than another, because that's where the core of the star may be exposed. And what we may be seeing there on the top would be perhaps where the core of the star is exposed. And there's more light coming from there then. So that's definitely a possibility.
Okay, Scott. So
this is amazing.
That was last night, your time, 8, 9 o'clock.
Yeah, it was just about 8:15.
Okay. 1 second.
What is the green?
Look, that's just when you do the color test.
Yeah.
Different coloration will make the picture either stand out or fade out. Look, it's no different than looking for something that's hot or cold. So the pixelation or the color pixelation will obviously be denser depending on the color, if that makes sense. And it'll actually form the object that you're trying to see through the color spectrum. Claudia probably understands that.
Yeah.
It's not hard to understand, really. It's just you're not manipulating the image at all, really. It's just you just want to see the image. So what you do is you just go through the color spectrum, and like everything's got colors. You know, everything's just because you see something in the sky that's red doesn't mean that you can't see it in a different color spectrum.
Mm-hmm. Yeah, so you're just shifting the frequencies up or down.
Yeah, it's like using a sound frequency. So all I'm doing is actually using a color frequency and just going up and down through the color frequency. Simple as that.
Yeah.
You know, and I've taught myself how to do this. No one's taught me. I just thought, well, if I wanted to find something, how was the best way to find it? You can either use magnetics, sound, or color.
Amazing. It's definitely a talent.
So I've never had any computer training at this at all. Never.
Okay.
Like I said, I just started doing it because I thought that was the right thing to do.
Yeah, you do a good job, brother. I could tell you that much right now. I mean, just viewing your channel over the last several months and your observations on those webcams and what you were detecting is pretty amazing, because so much is hidden. And I'll be honest, I mean, you know, when I took that picture with a cell phone. I mean, I got a pretty expensive cell phone with a good camera in it. But, you know, I took the picture. I thought, oh, wow, this is really cool. You know, the bright pink skies. I'll include this in a video just to show everybody. You know, excuse me, I'm choking on my own words here. I wanted to show everybody what the sky was looking like. And unbeknownst to me, wow.
You captured a light source, Scott.
I haven't been able to talk to you today, Scott, because I've just been flat out with shifting and stuff. So here's another couple of things, mate. Here's another couple of things, mate. All these are American. These are all from America. And at the moment, in America, I'm getting flooded with pictures. This is before the sun rose.
Oh, my.
This is from Mike in Missouri. So this, I've tested it. It's a standalone object.
Wow.
Completely standalone object. And this is as the sun came up.
Oh, my. Oh, my.
Holy shit.
Unbelievable pictures from from the Northern Hemisphere, especially in America at the moment. The US, I'm just getting so many great pictures at the moment. Here's another one from Devils. It's from a bloke called Travis. Look at this. Look at these.
Oh my goodness.
If you could expand on that a little bit so everybody can see a little bit more clearly on their screens. Oh my.
Oh, yeah.
I'll do live testing while we're watching.
Did you hear what I was talking about earlier when I was telling everybody about what the big NASA jumbo jet that houses the Sophia telescope, the one that they fly around? It's been flying back and forth for the last 3 days from Alaska through California, and at 39,000 feet, they are filming and recording and photographing the sunset. Mr. MMBB333 just dropped a video on it this morning. They've been tracking it on the website.
This is, like I said, this is actually a picture taken by an ordinary citizen in the US I won't go, because I'm sharing the screen, I won't go back into the email, but it was at a place called Devil's Horn or something in the Midwest.
Yeah, I've heard of that.
I'm not 100% sure.
Yeah, I've heard of that before.
But can you actually see that?
Yeah.
And
you see that object there?
Yeah, that's a standalone object. It's not anything else but, unfortunately.
Yeah.
Yeah, you could see that perfectly fine. I could see it.
Let me get rid of this. You can see it without even putting a thing on. That's inverted.
Wow.
Now, Claudia, you can clearly see.
Oh, boy.
You can actually see all the actual planets around it, mate. So you can see there must be at least a half a dozen, probably more.
Oh my goodness. Yeah.
And that's another big one just there.
Oh my, look at that.
And this is what I mean. If you do the color spectrum, they will show themselves. Because perhaps you can see it better when it's down lower, actually.
Yeah.
See that?
Yes.
Because you're actually using the pixelation to actually see the object. Sometimes it cancels a pixelation out, blurs it, so you can't actually get a good picture of it.
Oh my goodness.
What type of a program? What type of a program do you put these pictures in to utilize this coloring?
It's just Snagit.
Oh, okay, okay. I just bought Snagit.
Sorry, it's just GIMP. Anybody can download GIMP and start working with it.
Oh, okay. So you use GIMP. This is the programming GIMP that you're using to manipulate the photographs. Okay.
So there you go. There's 1, 2, 3, 4, 5, 6, 7,
my goodness.
8, and another big one over here. So remember, I was telling you the other night, Claudia.
Yeah.
In my honest opinion, you now have objects at 11 o'clock, 1 o'clock, and 6 o'clock. The one at 6 o'clock is the big system. It's got a huge cluster with it. I'll come out of this. And Scott, did you get a chance to see the video I sent to you today?
Yeah. I actually did watch it, and once again, I was like, "Wow, man! This is some good stuff."
Well, this is that picture, and I'll try and get. I think this is that picture. Yes, it is. This is from a live feed webcam, Claudia. Can you see that there?
Yes. Oh my.
See the size of that planet and the planet cluster?
Oh my goodness.
But they're actually not. It's actually this big. That's the lead planets. This is the cluster.
Wow.
I sent the video to Scott today.
Yeah.
Okay. You must show it to me. You must show it to me, Scott.
Yeah, it's wow.
Wow.
There's enough anecdotal evidence now to 100% say that these are 100% real.
Oh, Trig Point. That's Trig Point. That's down in your neck of the woods.
Yeah, it's about 5 minutes from my house.
Sure.
Can you see that now?
Oh, yeah.
Yeah. Oh.
Sure as hell ain't Mars or Venus.
No,
No.
definitely not. And
It's
the cluster,
amazing.
this here
Yes.
is that there.
Oh, my Lord.
Oh, it's
That's
reflecting on the water. That it's a light source.
Yeah, exactly.
It's a star. It's a star.
And it's bloody
Wow.
massive. It's huge. It is
Mm.
extremely large.
Oh my.
Whew.
Oh, this is unbelievable. Well, not.
You know,
I mean,
now
I've
we
been
know why
looking for
chemtrails-
this kind of evidence. Sorry, Scott.
Yeah, that's okay. That's okay. I was just saying that, you know, now we know why they chemtrail. Now we know why they chemtrail the living hell out of the sky.
Yeah, they do. You're right.
Geoengineering.
They don't want us to see this.
Even,
But
even
they
when
are
I
failing.
overpixelate,
Yeah.
even when I overpixelate, the only two things that stand out are that
Yes.
and that.
Yes.
My
I
God.
see that. Wow. Oh my God.
This is an interesting photo that one of our group over here sent me, which was taken. I'll show you the actual picture first. What's happened there? These are all the pictures that everybody sends me. This was a picture that was sent to me tonight or today.
Mm-hmm.
What's happening here? Oh, that's weird. It's shut down. People don't like me talking to you, Scott.
They don't.
Why?
That's
They think
weird.
we're,
Look at that.
well, yeah, they think I'm a fraud. That's the word they like to pass around. He's a fraud. He's a fraud.
Yeah. They think both of us are frauds.
What's going on with this? That's bizarre. I'm going to have to do it this way, I think. Hang on a sec. That's never
Okay.
happened before.
Okay.
I don't know if I can do it that way. Why is my screen so big?
I don't know.
Near the door? What's going on? That's
Maybe
just,
you're getting electronic opposition.
maybe. Okay, this was a really interesting pic. And Claudia, you'll find this interesting.
Yes.
This picture was taken at 2 and 3 o'clock in the morning up in the northwest of Australia, out in the desert. That's the moon.
Oh
That's not the sun. This was 2 o'clock in the morning.
Oh my. Look at all those objects.
Now, I don't know what these are. It looks like lens, maybe. I'm not sure. These here.
Yeah. Yeah.
And Scott will know this just from doing his research. You can't take a picture in the desert at 2 and 3 o'clock in the morning and end up with that on your camera.
Yeah.
No.
It's almost impossible. So there must be a reason why that's done that. Guys, can I just drop out for a minute because I've got to sort something out for my son.
Yeah.
And I'll come back.
Sure.
If you guys want to, I'll
no.
stop sharing for the minute.
Yeah, no
And
problem.
you guys keep chatting and I'll come back. I'll be back in about 5. All right, God bless you.
Okay. Okay. God bless. Wow.
Yeah, that's pretty. That's pretty incredible there. Whoo, man, let me tell you.
Yeah. Yeah, Scott, that's just unbelievable. Those are, you see, these are brown dwarf stars. These are light sources. This is, and to actually see them, because they always look like they're a bit diffuse around the edges often.
I can't believe I missed that.
Yeah, I actually saw it, Scott, but I didn't know if I should say anything.
Oh yeah,
Because I wanted.
You always say something. You have to.
I know, but I wasn't sure. I said, oh, I must look at that image more carefully. It looks like there's an object there, a huge, big object in the sky. You know, that object is huge, Scott. It looks larger than the sun would look to us in the sky. So these objects are smaller than the sun, right? So that means this object is very close to the Earth. Don't forget, these objects are about the size of Jupiter. So this object has to be very close to the Earth. And this is probably why we're seeing so many things happening with the magnetosphere. We're starting to build a picture of what's going on. I thought actually this was what was happening, but to actually see the object to me is absolutely amazing. It's miraculous.
Whew, man, look at that. I can't believe that.
It's amazing.
That is crazy. He shared a bunch of other photographs with me, and they were pretty amazing. I'm gonna let this charge up here, and we'll take a quick look at some of these that were sent in. You know, I was getting these bright illuminated skies like that back in the winter time, and they were pretty amazing. This photograph here, this photograph here, this came from a Cape Town webcam, in South Africa. I'm not too sure about what I'm seeing here. This may have been doctored.
It looks a bit like that cloud-like object that you saw in that Yellowstone footage. I wrote a little article on that. Like I said before, it doesn't look like the sort of solid object we usually see because it's not spherical.
Yeah, it's weird looking.
It's got, that's because these brown dwarf stars have a thick ring envelope around them, so they always have this thick ring structure to them. That's why they don't actually look spherical most of the time, unless we look at it so that the hole in the ring is facing us.
Now, I took these photographs yesterday, early in the morning. I think it was about maybe 10 o'clock, somewhere around there. And I could have swore I noticed something underneath.
Yeah, it looks like there's something there.
Right here under this big, thick ray of the sun.
Yes.
So I tried to reposition the camera, and I started to see it.
Yes,
right
I
there.
see it too.
Right here.
It is.
So I really didn't have a chance to examine the photographs, but there's something back here under the rays of the sun. So while we have everybody, we'll see if we can't adjust things.
Yeah. There's definitely something there.
I'm back, guys.
Hello?
Yeah, so okay. Yeah, we're examining a photograph of the sun that I took yesterday. There's something behind it, behind the ray of the sun, right here where my cursor is. Let's see if we could bring it out a little bit. So that. Woo! See, that's what you see. That's what NASA wants you to see right there.
Yes.
Yeah, they want to blind you. There's something right there.
Yeah,
and I've
you can
seen this
see
object
better now.
before. There's something right here. You know what exactly it is.
Well, it's large.
Yeah.
It's very large.
And the rays of the sun are over it.
Mm-hmm.
And this was just, I think this was just one of the photographs. I took a series of a few photographs back to back to see if I could catch it. And you could see the big rose petal look of the sun. And this was in the morning.
Yeah.
But I couldn't seem to capture it again.
Go back a couple of pictures.
There's our square sun.
Yeah, it's a simulator. They placed a simulator in front so we don't see these objects that are around the sun.
Yes, it's right there. I don't know what that is.
Yeah.
Because I was getting the rainbow effect of the prism.
Mm-hmm. That's right. It's simulator produces all these things to hide these objects.
Yeah,
and
then
there's something there.
Yeah, then Alan had sent in these stunning photographs. Is this what we were just looking at, Alan? One of your pictures?
Yeah.
That's pretty amazing.
Mike in Missouri.
Yeah, that's pretty amazing, ladies and gentlemen. I mean, you can clearly.
Oh my.
You can clearly see.
Look at
something.
That.
If you actually look at the top, if you look at this top image here, if you go in a bit closer, it's not just that. There's other planets. There's actually objects with it. 1, 2, 3, 4, 5. This is a system on its own.
Yeah. Yeah, well, we should expect these brown dwarf stars to planetary systems, but look at the color. It's amazing.
Oh, I see them now. Okay. Yeah. You are right.
Yeah, it's definitely that. It's a light source with planets, or star with planets.
This gives you a good indication
what we got here.
This thing gives you a good indication of what happens on different light spectrums.
Yeah,
have a look at the back up here.
Oh, you want to share your screen?
Yeah, sorry. Yeah.
I'll dip out of mine real quick. Okay, there you go. It's all yours, buddy.
Okay, is that it?
Yeah.
Well, I was going to finish showing you the other picture anyway, so I'll finish that, if you don't mind.
Not at all, brother. Not at all. Good to have you here.
So that was you obviously saw the other picture with the reflection at 2 or 3 in the morning, which just doesn't make sense. If you're taking a picture of the moon at 2 or 3 in the morning, why have you got a reflection showing 3 possible objects? It doesn't make sense.
No, it doesn't.
You shouldn't have a reflection, even if it's a full moon, which it is tonight. Then you shouldn't have that big a reflection, because the actual sun or the moon is not. It's a reflector in itself. It's actually not a light source. It's a reflector.
Yeah.
Does that make sense?
That's right.
So, this is what I found coming from that. So I tested it. And these are the objects that are in that picture. The thing is that the sun, the moon was coming down, illuminated these, and Sam, the guy who took these pictures, inadvertently took a picture of what was in the sky, but he didn't realise it because it reflected off the thing came out over here.
Oh my.
Well, there you have it, everybody. Since we're going to be having a few days of full moon, try to get out there and let's get some photographs of the moon. Try to make sure you don't overexpose your images. And let's see if we capture something.
Yeah.
There may be a high possibility.
Mm.
Right.
Okay.
If you want to capture these, the best time to capture it is, in my opinion, is as the sun's going down and they're chemtrailing the crap out of the sky, then that's the best time. And after the sun's gone down, just keep your eye on the western horizon, around where the sun is. Put it that way, from about 4 o'clock onwards.
Okay.
And I still believe that there is something in the eastern horizon at the same time when the sun's coming up, if that makes sense. We're trying to figure that out mathematically at the moment, Claudia, and I'm not the person to do that. But that picture that I showed you from Mike in Missouri was pretty clear that there was something in the eastern horizon.
Yes.
But we don't understand. Is that an indication of just how big this system is then? If you're seeing it in the east.
Now, I think it's not just one system. That's the thing, Alan. I think we have many systems that have come in. Many brown dwarf stars have come in, and they all, it could be that some of them are binary or trinary systems, in other words, with 2 or 3 stars in them. But basically, we have many of them. We have tens. I've said before we have at least 5, but I think now we may have a lot more than 5. We may have 10 or 20 brown dwarf stars close to the sun or in the inner solar system. And some of them are not that bright yet. We are seeing the ones that are emitting quite a lot of light now. That's what's happening.
Okay, this is a good picture, because this clearly shows you. Get to about there. You can see the rays coming down, but you can clearly see that this is over the top of those rays.
Yes.
Can you see that you're in?
Yes.
And there's another one right next to it over here.
Yes, I see it. I see it. Yes, I see it. Wow.
And
but you know, if we are seeing these objects because they happen to be close to the moon.
Yeah,
now that tells you.
Yeah, is that the moon's getting some light source off the moon. You wouldn't see them otherwise.
That's right. So, but that tells you how many of these objects really are around, because we could have the sky full of these objects and we wouldn't be able to see them. But chance, I mean, the probability of us seeing 3 objects in one night, just because they're at the right position, is very small unless there are many objects everywhere.
Yeah, there has to be multiple objects, and again,
there are many.
Yeah, I mean, I have to stick with my theory, based on all of the research that I've done is, I mean, just thinking about Jupiter and all of the moons and objects that orbit around Jupiter. So these brown dwarf stars, regardless of how big or small they are like super magnets in space. So as they travel on their journey, if they do come by a small exoplanet, the exoplanet doesn't have a chance. It's going to get sucked in and then probably placed in an orbit, just like Jupiter. Those Those conferences that I listened to from Harvard University with all of those astronomers, scientists, and astrophysicists for 3 hours going over the information on the brown dwarf stars that they found with, I think it was that WISE, the WISE telescope that takes the big, picture plates of deep space. And they found they found brown dwarf stars with other objects orbiting around them. So the possibility is like super high.
Yeah.
Just stands for reason, doesn't it? We're not here on our own. Hey, I want to show you this because this is an interesting thing that the High Truth channel did the other day. If you haven't watched this,
yeah, I saw his video.
Yeah, it's a great video. But the funny thing was, he was debunking this picture, and you can clearly see that he's got some legitimacy to his thing, because this yellow stripe is actually sitting over the top of the actual sun rays, which it shouldn't be. It should have been sort of next to it, but it shouldn't override it. So I'm a bit dubious about this whole picture. But what happened was he went to the next picture. Can you guys see this? I know might be a bit smaller on your side.
Yeah, you know what? If you want to go back down to your bar at the bottom of your screen and click on the share screen, the blue share screen button, and I'll show you.
I thought I did.
Let's see here.
You're not seeing this?
Yeah, we're seeing it, but I'm going to show you. I'm going to show you how to expand your screen so everybody can see it.
I can expand it. My end, is that better? Can you see that now?
Yeah. I mean, the next time you share your screen, I'll show you how to go full screen instead of sharing just your monitor screen.
Okay. What I'm trying to say is that in the video that he did, if you notice this yellow going over the top of the white, Strop and I talked about this, and the guy's right. I don't know why that's like that, but this wasn't what I was actually looking at. What he was actually showing us is that image. But if you look at the water just here, can you see these reflections on the water?
Yes, I can see. Oh my God, those objects around the sun.
Yeah.
Oh my.
So while he was debunking the actual picture, which he was probably right about, I don't know where this came from, but in actual fact, the actual picture is actually telling us that there's objects in the sky.
Yes.
Note that there is something clearly visible above the sun, i.e. a black dot, which you can clearly see is there.
Oh my.
So I don't know. So I did a bit more searching on it. And that was the second one.
Sure.
And then he went to this shot, which clearly shows you that there's something there.
Wow.
Reflection in water that missed HTC, Mitch. Remember that water does not lie. And you can see the reflections. Whenever they've tried to cover these up, it's kind of funny. They've always forgotten about water. With water, will always show you.
Yeah.
Will always keep the reflection. That's what he was trying to point out, that shouldn't be there like that. And he's probably correct.
Yeah.
But these here were always here anyway. This might be put here just to add some impetus to the shot. I'm not 100% sure.
Yeah. Amazing.
But then when you look, if you go back and look through the video, the reflection in the water there, reflections in the water here and here.
Wow.
I sent them to everybody the other day.
Okay. This is amazing.
This is a pretty cool picture.
Mm. Wow.
Now we've come up with this might be the sun.
Mm-hmm.
But what caught my attention was the way this was illuminated around the sun.
Yes. Hmm.
Sorry, wrong picture. Oh, that's the
Yeah,
Missouri
which
one.
one is the sun there? That's a very strangely shaped object there.
Yeah. So this was taken on the top of a mountain in Scotland, August 8th, 2016.
Mm. That is, yes.
I'll see.
So there's more than one object, more than one source of light there.
I'm going to try and show
Basically.
you this. Just 1 second, Claudia.
Okay.
You can have a look at this.
Mm.
Can you see this thing here?
Yes. Oh my goodness. It's another one of those systems, isn't it?
That's a huge planet, right, sitting right next to the sun.
Oh my goodness. But there's something causing the extra light as well, isn't there?
Well, that's what I wanted to ask you.
Okay. So if there's a huge object like that, that huge object could be like the one that Scott caught, that's much closer to the Earth and illuminating the Earth's atmosphere with its own light. That's what I would think it is.
There you go.
Because don't forget, it's not. Yeah, it's not normal for the atmosphere to look red when the sun looks yellow. The atmosphere would have to be yellow as well, or white. So for the atmosphere to look that orange when the sun is paler would mean that another object is illuminating the atmosphere. So that could be that object that we see there.
This is how I do these. If I go down to 0 brightness, you can still see it.
Yes.
If I go right up, you can still see it.
Oh, yes. But it looks like it's got a hole in the middle. That's what I see. And when I see that little hole, you know, the dark spot in the middle of it, I think brown dwarf star. Brown dwarf star. Whenever I see that. That's just typical of them. Because they have this envelope around them and a little hole in the envelope somewhere.
I don't know if you've actually seen this one yet, Claudia, because I did a video on this well, last week, I think it was.
Okay.
So you might not have seen this, I'm not sure.
No, I don't think I have. I've been busy writing articles instead of looking at you. Sorry.